Let's find the length of part of a parabola f of x equal to x squared over the interval x between 0 and 1. It's easy to see what this problem is asking when we sketch the parabola and take the 2 points. X equals 0, y is 0, so we're at the origin. When x equals 1, y also equals to 1, and we're right over here. So what we want is the length of the part of the parabola right there, that piece. If we were able to, if this is a piece of wire, we can just flatten it out and then measure it, find the exact length. This is what this problem is going to do. The formula for finding arc length of a curve y equals f of x for x between a and b is given by the integral from a to b of the square root of 1 plus f prime of x squared. This formula is going to be derived in a video that follows this one, maybe a few videos down. So check if you want to see how this formula is derived, why it's true, you can check. But for this problem, we can just use this formula. Take prime f prime of x, that's 2x, and the length of the parabola when x is between 0 and 1 is the integral from 0 to 1 of the square root 1 plus f prime squared, which is 4x squared. Now, what we're going to do is leave 0 and 1 alone for just a few minutes until we actually find antiderivative, and just concentrate on finding that antiderivative. We're going to use trigonometric substitution. The substitution is we take 4x squared, take its square root, that becomes 2x, and set that equal to tangent of theta. Then squaring both sides, 4x squared becomes tangent squared theta, and what we have inside our radical, 1 plus 4x squared, with this substitution now looks like 1 plus tangent squared theta, which is secant squared theta. Now differentiating both sides of our substitution, we get 2dx also equals to secant squared theta d theta. So dx is 1/2 times secant squared theta d theta. Let's go back and substitute. We have inside the radical 1 plus 4x squared. That's now secant squared theta. And then dx is 1/2 secant squared theta. The integral becomes 1/2 times the integral of secant cubed theta. And this is one of those integrals that you should know. It's derived in an earlier video. So if you scroll up in the website, you can find this the integral of secant cubed derived. It's equal to 1/2 secant theta tangent theta plus 1/2 natural log of absolute value of secant theta plus tangent theta. So overall, the integral in variable theta is 1/4 secant theta tangent theta plus 1/4 natural log of absolute value of secant theta plus tangent theta. Now let's go back to variable x. Remember, our substitution was 2x is equal to tangent of theta. So we already know what tangent is. We just need to find secant. Let's draw a right triangle. It's a right angle. This is our angle theta. Tangent is opposite divided by adjacent. So if opposite is 2x and adjacent is 1, then tangent of theta is 2x. The missing side is the hypotenuse here, and that's equal to, by Pythagorean theorem, 1 square root of 1 plus 4x squared. So now let's go back to our integral. Our integral was the integral from 0 to 1 square root of 1 plus 4x squared dx. We just evaluated the integral using the substitution. We had 1/4 times secant theta. Secant theta here from this triangle is hypotenuse over the adjacent, so that's just the square root of 1 plus 4x squared, times tangent of theta, that's 2x, plus 1/4 natural log of absolute value, again secant, which is square root of 1 plus 4x squared, plus tangent, that's plus 2x. And that's evaluated from 0 to 1. Let's plug in 1. It gives us 1/4 times, plugging in 1, we have square root of 5, and then times 2, plus 1/4 times natural log. We actually don't need absolute value because everything will be positive, square root of 5 plus 2. We then have to subtract when we plug in 0 for x, but if you look closer, when we put in 0 for x, everything is 0. So this is our answer, and this in fact equals to, if we simplified, one way to simplify it is to keep 4 in the denominator, so we can write it as 2 times the square root of 5 plus the natural log of square root of 5 plus 2, and then this is divided by 4. That's the length of this curve over the interval x between 0 and 1. For more videos, visit www.mathprepvideos.com.